All right, good afternoon, ladies and gentlemen. So, this particular video is going to focus a little bit on the idea of static electricity. Now, what we're going to find out is that this week we're going to be moving very quickly. So, we're going to be flying through talking about static electricity. Then, we're going to talk a little bit about electricity and circuits in general this week. So, if it seems like there's a little bit more material this week than normal, it's because we're going to try and finish this entire unit on electricity basically in 1 week. All right, because this is not coming to the AP exam, which is not to say that I don't think it's important that we talk about it, but I do want to focus on the last unit, which will be on the AP exam. So, with that being said, the first thing that I want you to do is that if you've not already done so, I want you to watch the Bill Nye video on static electricity. And that's the great big surprise that I announced. You're going to get a chance to see exactly how great static electricity is. And of course, it would have been in the classroom. It would have been basically a shot-for-shot replica of exactly this video. But unfortunately, we don't have a classroom, so we have to go with what I guess is subpar education. But Bill Nye still does a pretty good job. So, with that being said, if you've not watched that video, I highly recommend you pause it, take about 23 minutes, watch that video. Because it is going to explain a lot about what we're going to talk about, and I'm going to kind of talk about these notes under the assumption that you have done that. All right? So, if you haven't watched the video, if you haven't watched Bill Nye, pause this video right now, go watch it, and then come back. All right? So, hopefully, at this point, you have watched that video. So, the first thing I want you to do is your warm-up is I have a ring. It's a little drawing to the right. It's a ring of of negative charges. And I want to put basically I want to put a proton somewhere in that circle so that it will not move at all when I let go of it. All right? Now, I just want you to take like 30 seconds and I want you to think about where should you put that proton so that when I let go of it, it's not going to move at all. So another way of saying is it's in equilibrium. All right, so take like 30 seconds. All right, so hopefully if you look at that, that ring is symmetrical, and that is going to be important because all those negative charges are going to apply different forces depending on where you put that positively charged particle. And the only place where all of those negative charges are going to exert the same amount of force is going to be in the middle of the circle. So if you put that proton right in the middle, all of those negatively charged particles are going to basically exert forces that cancel each other out, which means the forces will all be balanced. All right? Now, moving past that, just a quick little warm-up. We've already talked a little bit about the three types of charges. So we talked about the idea of positive charge, negative charge, and neutral charge. All right? Now, of course, neutral means that the positive and negative charges on the object are the same. If it's negative, it means it has more electrons than protons. And if it's positive, it means it has more protons than electrons. Okay? And when we talk about electricity, electricity focuses specifically on the movement of one type of charge, which is the electron. All right? Now, for us, the most common way we experience that is through what we consider static electricity. And it's a term that you've probably heard multiple times, especially whenever you shock yourself on a doorknob. People will talk about, oh, it's static electricity. And we're going to take a couple of minutes just kind of talk about exactly what that is. Okay? So the first thing we have to understand is that all static electricity is basically charges rebalancing themselves. Okay, and to do that, we need to kind of ask ourselves, how can we actually cause charge to build up on something and produce static electricity? So this is where the little online lab I want you to do is going to be. So I want you to kind of right click, just go to this online lab. I'll just click on it and open it. It should look something like this. And what you're going to do is I just want you to kind of follow the particular questions right here, here, and here. So basically the four questions that kind of go before it says how charges decide to move. Play around with the balloon a little bit, see what happens. You can also do this if you have access to a balloon. You can do this at home in person, which is what originally we were going to do in the classroom. So take about, 4 or 5 minutes, work through those four questions. So pause this video, work through those questions. When you come back, unpause it, and we'll talk about what you saw. All right, so hopefully you had a chance, ladies and gentlemen, to work through those four questions. This balloon is an excellent example of charging things via static electricity. So if we kind of look at the lab, you'll notice that all of these objects, the three that we have so far, this wool sweater, this balloon, and this wall, They all right now are neutrally charged. They have the same number of protons and electrons. All right. Now, the first thing I ask you to do is I want you just to figure out how to charge the balloon. And hopefully what you kind of figure out is that you can click on this, start moving it around. And if you kind of took it over to the sweater and started rubbing it against the sweater, that's what it's doing, you'll notice it starts to pick up these negative charges. Okay? And of course now something kind of weird happens because now it's negatively charged. And you'll notice that when I stole the negative charges from the sweater now becomes positively charged. Okay? Now, because of this, what I've done is now created something that's negatively charged and positively charged. So, of course, they attract each other. And when I let go of this balloon, it starts to move towards the positively charged sweater because it wants to go towards the positively charged particles. Okay? Now, electrons are rather interesting because they're quite fickle. They're more than happy to move from different objects if you kind of have them come in contact with each other. All right, electrons are always looking for the best deal possible, and sometimes what we find out is that they're very easy to steal from one object to another. Now, in this case, they've gone to the balloon, and if you take this balloon, which is now negatively charged, and you start to move it towards the wall, you'll notice that the negative charges in the wall don't just sit still. All right, they're not really pleased about this situation. Remember, all negative charges hate being near other negative charges, so they're going to do everything in their power to move away from them. And in this case, what's happening is basically the balloon forces those negative charges away. Now, while I haven't stolen any charges from the wall, what I've actually done is caused a section of the wall to now become positively charged, that one little section, which means that now our negatively charged balloon is actually going to stick to this positively charged section. All right? It's part of the reason why you can make things stick. Something's charged, you can make it stick to something that is neutral, because what you've done is actually created a section that is not neutral anymore. It's charged a certain way. All right? Now let's see. Electrons fickle, back to the line lab, blah, blah, blah. Localized section of wall is actually positively charged. So hopefully those are some things you saw in this lab when you were playing around with it. Okay? And what we're going to find out is that exactly how we can create this kind of charge imbalance in certain things. Okay? Now, charges follow rules. They don't just arbitrarily decide how they're going to move. All right? It's a physical quantity, and just like all physics, it has to follow certain rules. And there's one very important rule it has to follow, and that's the law of conservation of charge. Okay? And what that means is that basically you can't destroy charges. All right? Charge has to be conserved. So whatever the total charge, and it's going to start to sound like the law of conservation of energy in a little bit, whatever the total charge of a system is, that has to be the same before and after whatever I do. All right? So in this case, if we go back to our balloon, what that means is that if I reset, right now if I look at just the sweater and the balloon, the total charge is 0. All right? Because a neutral charge has 0 because they add up to get, they basically, the positive and negatives all add up to cancel each other out. On the balloon, it's the same thing. Now, when I rub these two things together and I make a negatively charged balloon and a positively charged sweater, even though now these two things technically have charge, the law of conservation of charge specifically says that it's still, if I drew a big circle around these two things, the total charge is still going to add up to equal 0. Okay? But that governs how charges move a little bit, because we're going to find out is that if you have things that are have different charges, okay, we're going to find out that they're going to try and do their best to balance each other out. So if I have something where charge can easily move in objects and something's negatively charged and positively charged, and I put them together, the charges are going to kind of equalize themselves out so that both objects have the same charge if it's possible for the charges to move. Okay, and I know I just said the word charge a lot, and I just said a lot of words. Basically, charge wants to be balanced, just like everything in life. Now, let's try it out with a little example. So, I'm going to take a neutral balloon, and I'm going to rub it on my neutral hair. And this is an example. Literally, you can do this at home if you want. You can do it with a comb. You can do it with a balloon. It doesn't really matter. Afterwards, the balloon has a negative charge of negative 3 nanocoulombs. So that means it's picked up electrons. So now I want to know how much charge does my hair now have? So just take 15 seconds just to think about it. And think about the idea of what the law of conservation of charge says. Okay, so hopefully, thinking about the fact that charge can't be eliminated or destroyed, you thought about the fact that, oh, this must mean that the charge, if it starts at neutral on both cases, the total charge is 0, which means that afterwards, if the balloon has negative 3 nanocoulombs of charge, my hair must now have positive 3 nanocoulombs of charge as well in order to make sure that they add up to equal 0. All right? Now, objects generally don't like being charged. All right? And the reason is because electrons, that we've talked about, absolutely more than anything else in the world, hate other electrons. All right? Now, if I'm making something negatively charged, the electrons that are being added to it are getting more and more upset because they're desperately trying their best to get away from other electrons. All right? Which means that if we charge something and we give that charge a path, we can actually move those electrons somewhere else. All right? And what we usually call that is that if we take a charged object and we give it a path for the electrons to escape, we refer to that as grounding. All right? And basically what happens is if I have something that's negatively charged and I ground it, so usually you just touch it with a piece of wire and that wire goes into the ground, the electrons now have a path to escape and they all go through the wire and they go into the ground and the object becomes neutral again. All right? So just to recap right now, we talked a little bit about how we can charge things. We talked a little bit about how charges try to move and what they're trying to do when things kind of rub together, and the idea of the law of conservation of charge. All right. So at this point, I'm going to pause this particular video, and I'm going to kind of start recording the next one because I'm going to go over the time limit for my little video recorder. All right. So jump to video 2, and we'll talk about the second page, please.